Students, welcome back to part 2 of lecture number 18. So, here we are going to discuss about data preprocessing, but let me tell you why data is so important. I do not need to tell you again and again, right, because you are talking about material data science or informatics. So, data is the important aspect, without that you cannot do anything, and you must know where from you are getting data. You must also know the source is authentic or not very clearly. You cannot take data from any sources, and what will happen is that if you are collecting data from any sources and model it, you will find your results are not inconsistent. They are highly inconsistent because your quality of data are not good. You have not taken the data from very authentic sources. So, therefore, you must be very careful when you are collecting data. You will find the internet, there are many open source data platforms are available, right. They are going to give you data free of cost, but as I told you, in future it is not going to happen, because future data are going to be critical. Nobody is going to share data, you have to buy the data, and when you buy the data, you must check authenticity of the source from which you are buying the data. This you have to keep in mind. Let me also tell you that whenever you are modeling, you are using part of the data for testing the model and part of the data for training the model. Many people use 80-20 ratio for training and testing, 80% data for training, 20% data for testing. Once you train the model using the training data, you test the model using test data, and that should match. This is one way of checking the quality of your data. And lastly, once you have developed the model, you have to evaluate the model. So, we will discuss about evaluation maybe sometime later, next class or so. So, therefore, there are many steps in which you can do that, but nonetheless, once you get data, you have to preprocess data most of the cases. So, there are different types of data or forms. First is attribute values data, correct. Attributes that's a feature. So, they can be like A1, A2, A3, A4, AN, and then you need to know their values. You can also have different types of data like numeric data, which is very easy to understand. You can also have categorical data like hierarchical relationships, just now I talked about it. Then you have a static data versus dynamic data. Dynamic data means temporal, time dependent. There are other kinds of data also possible like distributed data. Distributed means some kind of a distribution functions. You can also use text data, web data, metadata. Then you can also collect data from images, audio, video, right. So, hence we are living in the data world, okay, that is what I can say. So, these different types of data cannot be same. So, then the question is why you need to preprocess data. Furthermore, we will discuss about cleaning, integration, transformation, reduction and discretization of data. So, data in the real world, as I said, are not clean, rather they are very dirty. Why? Because you can always have problems of noisy data, incomplete data or inconsistent data. Like you can have missing attribute values, lack of interest sometimes do not allow, lack of interest sometimes does not allow you to collect all the data. Suppose you are doing experiments and you are interested to collect data, you are required to collect data every hour, but you are collecting every 2 hours data. That means you have lot of missing data, is it not? So, this interest of seriousness can create lot of incompleteness, lot of problem in terms of complete data sets. Sometimes we even collect data, you must have seen the many surveys, some row or some columns remain vacant. Unknowingly or knowingly you do that. So, that creates incompleteness. Noisy data, well, that is very common in real life. So, we forget to collect data, then we can place something, some numbers, so jot down some numbers from our mind or something. So, then noise data becomes very erroneous or noisy. And most importantly, people actually always talk about inconsistency of data. It will contain some kind of inconsistency. Let us say you have collecting age and birthday, right. Here I am given an example. So, if somebody is born in 1997 and I say age is 42, that means I am wrong. Today is 2025. So, 25 plus 3 is 28 years. It is not 48 years. You can 42 years, right? So, that is a inconsistency. You can always easily find out that. Sometime you go to a some restaurant or something, they will ask you to rate, either rate in terms of ABC or 1 to 3. So, 1 to 3 is numerical, you can understand, but somebody asks you to rate 1 ABC, how do you convert into numerical data? That is a problem, right. So, that means scale has to be very consistently done. Sometimes you can also have discrepancy between the duplicate records. Somebody has copied it something, data sets, while duplicating, the duplication was not done properly, it can create discrepancy in terms of duplication also. So, if there is this kind of problem, your data quality is compromised, you cannot do good data mining or good data science, right. Quality decisions must be based on quality data. Duplicate, missing data can always create a lot of problems in terms of misleading statistics. So, that is why data preparation, cleaning, transformation, they are very important in data informatics applications. It is almost 90% of the time you are going to spend in this aspect. This aspect means data preprocessing approach. Well accepted techniques to improve the quality of data. There are certain parameters which are used basically. First is accuracy, completeness. Remember this, accuracy, you must have accurate data, you must have complete data, you must have consistent data. Some data are updated, right. It's like you are calculating data of motion of a star, right. So, it varies depending on the session, depends on the time of the year, star is moving, earth is moving, star is moving, or maybe none of this moving. So, you must have timeliness of the data. This is very common problem in many of our scientific problem, material science, like thermodynamic databases, right. You will find lot of different databases available at a particular time. After a few years, these databases are merged and create a new one. So, timeliness is very important, it should be available in the time we have. Then you have problems of interpretability, believability, value addition, and lastly accessibility. That is why this free data sources wherefrom you can get data free is very popular. They are very easily accessible, but you have to take with a pinch of salt, because easily accessible means data quality may be compromised, and interpretability also will be a problem. So, that is why you have to always look for data which are authentic, which you think authentic. That is why the believability comes into picture, brand value comes into picture, whether can you believe certain warehouses or certain company who are providing you data. So, these are the aspects which are used, these are qualitative terms, interpretability, accessibility, value addition, believability, and these top 4 are basically where you can really talk about in terms of numbers. So, let us say data cleaning, filling in missing values, smoothing of the noisy data, identify and remove the outliers and noisy data, and resolving the inconsistencies. These are the key things in that. Sometimes you have to integrate data from different sources of files. This is very common. You are taking data from one source and also from other source. How do you integrate that? They may not be having same number of columns, same number of rows. That is okay, that can be handled. I am not talking about that, but they may not have same units, they may not have same kind of way representations. So, that is it, that is the problem you have to understand. Many cases you have to normalize or aggregate the data, that is comes under the data transformations. Sometimes your problem requires to reduce the dimension from high dimension to lower dimension to get a better mathematical understanding of the problem, and also for numerical data you need to know about discretization. So, first let us talk about the cleaning. It is the number one problem in data warehousing. So, there are several things I told you, filling the missing values, identify the outliers or noisy data, correct inconsistency, resolve redundancy or data integration. Okay. So, what is the missing data? many tuples have no recorded values, several attributes such as customer, income in sales data. So, missing data may be due to equipment malfunctions, inconsistency, not entered because of misunderstanding of the person. Certain data may not be considered important by the person at the time of entry, or there is no history of registration, right. That is also possible. So, hence you have to solve this problem. So, why would you solve this problem? That is why you have to use some kind of algorithm. People use like inference based algorithm like Bayesian formula, probability based, decision tree or EM algorithm also used. I am not taught about EM algorithm, but I also can be used to do that. Okay. So, how do you take care of noisy data? Well, random error or variance in a measured variable. So, you can have faulty data collection or data estimation problem, many other things can lead to noisy data. Okay. How do you handle that? You can do binning method. First, you sort the data partition into different bins. It can be equi-depth or it can be non-equi-depth. Then you can smooth by bin means mean, actually mean of the data, or you can smooth by meridian or median or boundaries depending on that. This is very common technique. So, binning is the most widely used method. You can also use clustering. You can detect and remove the outliers easily. That is that clustering I talked about it. You can even combine your knowledge, inspection ability and computer, computer combined approach of computer. Both you can be together and you can create a better sense of which one is outlier, which are not outliers. Like in case of binning data, let us say you have sorted data and prices in dollars 4, 8, 9, 15, whatever these numbers are given. You can bin into like this, equi-depth, smoothing that bins. You can see this is how you smoothen. Sometimes it can give you wrong results, sometimes it can got better results. If you bin by means, it will look like this. If you bins by boundaries, it will look like this. Both of them are not perfect, right. So, you have to keep trying that this kind of methods. Outlier removal is another key aspect. You will find many experiments, the data are collected, but there will be always outliers. Okay. So, removal method is clustering or curve fitting. You can always fitting a curve or clustering. Sometimes you can actually have a physics based understanding, hypothesis testing also is possible. That is also possible if you have understood the problems very clearly. Now, you can how do you integrate data and transform data, that is something also you should know. Data integration is very common nowadays, because you will be collecting data from multiple sources. Schema integration is what is widely used, integrate metadata from different sources, that is one. Then thermodynamic databases, okay. Collect data from multiple metadata from multiple sources and put them together. Identify the identification of the entity problem is very important. Okay. So, you can have multiple data sources like A customer ID or B customer ID something, and how do you identify that they are having similar data sets, so that you can integrate them. You cannot integrate A and B or apple and bananas together, right. You have to have same sort of data points exist or data entries exist in both the files. So, it can lead to data value conflicts, and this is very common, like different scales like matrix versus BTC units is highly possible. And many cases you may have to remove the duplicates data or redundant data also. This is another problem. Lastly, you have to also transform data, smoothing or removal of noise from the data, and data transformation also requires you to normalize. Many cases you will see you have to normalize the data scale to fall within a small specified range. Sometimes you may have to use attribute or feature constructions, you may add new attributes from the given ones, aggregation, summation, generalization, these are all things we always handle when you transform the data. So, these are the various aspects. So, let us talk about normalization. Minimax normalization is very common. You can see the new variable b prime, a b minus min a divided by max a minus min a. You can also z-score normalize b minus min a divided by standard deviation. You can also do a decimal scaling divided by 10. So, all kinds of normalizations exist. I am discussing only few of them, not discussing everything. Lastly, what is about data reductions? Many cases you will do that actually. So, I may not discuss much about data reduction principles. Professor Pratik Ray will discuss some of these. Data is too big sometime to work with, huge amount of data, and the real life we always do data reductions. Okay, let me give you an example of data reduction. I think I have somewhere down the line I wrote about it, what is data reductions or something. Okay. So, basically if I consider a 3D problem, 3D to 2D is, this is what it is. Let me just go to the board and explain you why you need to have data reductions. Probably that is the very important. Okay. So, let us say I have a 3-dimensional figure like this. Let me draw it. Okay. 3-dimensional figure like that. I hope you can see very clearly that this is a 3-dimensional figure. So, let me put number exactly what is I have in this book, 5, 8, 7, sorry 7 is here, 7, 12 arbitrary numbers. Okay. So, now if you know we always take, so this is nothing but representing object, the 3D objects to a 2-dimensional objects, right. So, so we take front views and side views. So, if I take a front view from this side, how it will look like this side, okay, this direction, this is the front view. So, this will look like this. Five, 8, 7, right. This is what is a front views. Now, what is your right side view? This will be little longer. So, 5, 18 right side view. Okay. And 12. Will come here. This is the one. Okay. So, that means what? This is your right side, because there are 2 side views. And you can also have a top view. Top view will look like this. (15, 12, 38). Now, look at this picture. So, this is how we can reduce certain dimension. Okay. Why do you do that? Because if you have this side views and top views and front views, we can create a 3-dimensional picture. This is what is taught in your engineering mechanics. Many of us learn that. So, dimensionality is reduction is required cases where goal is to summation the data in a reduced number of dimensions. While you do that, we must not reduce, we must not reduce the problem. Okay, remember this. Dimension reduction is very important, but it must not do that. So, it always removed unimportant attributes. It can use aggregation or clustering, sampling. Not only that, it also requires some more things. Important aspect of dimension reduction is to ensure that meaning and the sense of the actual data is written. Meaning and the sense of actual data is written while dimensions are reduced. You cannot compromise the meaning and the sense of the actual data. This is important because when you reduce the dimensions, the information starts getting distorted, right. For example, I showed you these objects. If you look at front view or top view, information is distorted compared to 3-dimensional view, right. So, that is the key problem. So, if you therefore, if it is critical to select features subsets in such way that the actual meaning and the intent of the original data set is retained, actual meaning of that. So, we always remove unimportant attributes. You must know how to detect the unimportant attributes. That is why the feature selection is very important. Select the minimum sets of attributes or features, minimum sets of attributes or features that is sufficient for the data mining. You can use heuristic methods, stepwise forward selections, backward eliminations, combining forward selection or backward eliminations. You can use that. You can also use popular data reduction technique like histograms. You can bucket the data into different averages and do that, or you can also use clustering, partition data into different clusters. That can be effective if data is clustered, but not smear out, smoothen out. It is okay, but smear out is not okay. There are many choices of clustering definitions which I will not discuss much. So, and you can also use sampling. You can use different adaptive sampling methods like stratified sampling or simple random sampling methods can also be used. So, these are the different ways of sampling, like raw data sampling. You can see these are different 3 samples. You can use stratified samples like this. Stratified means exactly what you want to be stratified. Okay. So, last thing which I will discuss in couple of minutes is discretization, and there are 3 types of attributes you have seen. You can have nominal attributes, value from an unrecorded unordered set, ordinal or continuous like real numbers. So, discretization means what? Divide the range of a continuous attributes into intervals, because some data mining algorithms will only accept categorical data like yes or no, okay, or 0 or 1, but some other things, some other algorithms requires you have continuous data. So, that is why you can use binning methods, equal weight, equal frequency, or you can use entropy weight methods also. So, discretization can allow you to reduce the number of values of a given continuous attributes. It can also allow you to reduce the data by collecting and replacing low level concepts by high level concepts such as young, middle aged or senior instead of numerical values for attribute ages, right. So, instead of using numerical values of attributes, you can use young, middle aged or senior kind of aspects. Binning is something I already discussed about it. You can use equivalence binning or width binning, or binning from the surfaces. Otherwise, you can use entropy based, right. Entropy based binning is something which is widely used now. Intuitively is called, it can find best split, so the bins are as pure as possible. You go back to my entropy definition for these entry structures, you can always use that. Entropy is defined as like this: p log p minus n log n, where np everything is given here. Let us say S is a set which is denoted by 8 pairs. So, 9 pairs. So, p is 4 by 9, the fraction of p pairs, and n is 5 by 9, the fraction of n pairs. So, therefore, entropy is minus p log p minus n log n. So, molar entropy means set is relatively pure, and larger entropy means set is mixed. So, you can actually discretize by using entropy better way than this. So, entropy based techniques are more widely used now, and you can always get of information entropy also, you can see that, and you can get entropy gain also, like information gain. So, you go back to my lectures on that. Goal is to split with the maximum informal gain. Okay. So, best split is always found after examining all the possible splits. So, these are the techniques we use for data discretizations. So, I am going to stop here, and let me tell you that data preprocessing is very critical. You must follow these slides very carefully to understand different techniques which I have discussed about it and read more about it. Thank you.